Okay, so now let's discuss a very important theorem. This one is a theorem that enables us to factorize cubic expressions, and it plays a vital role as well when it comes to the solving of cubic equations. Okay, so this is what we call the factor theorem. The factor theorem. Okay. All right, so the factor theorem basically states is that if we have a division, okay, a of x over b of x, okay, we know that this is equal to q of x plus r of x over b of x. Okay, we established this in our previous sessions. Now, the factor theorem states is that if a of x is divided by b of x, okay, whereas b of x is, let's say b of x is cx minus d, okay, b of x is cx minus d, and then we find that, and then it is found that the remainder, out of x is equal to 0, okay, then it can be concluded that b of x is a factor of a of x. Okay, so we say that a b of x, okay, not a of x, we say that b of x, then b of x is a factor, of a of x. Okay, so b of x is a factor of a of x if this is the case. So basically what we are saying is that if we take a polynomial or an algebraic expression a of x, this one, and then we divide it by another algebraic expression b of x, and then we find out that this guy, the remainder, is equal to 0, or that division produces no remainder, then we conclude that the expression of b of x is a factor of a of x. Now, let's talk about this idea of a factor for a moment. Okay, so what do we mean by something being a factor? Okay, so let's take this numerical value 6. Now, we know that if I divide 6 by 2, I will get a value of 3 with no remainder. Okay, so because of this, then I can conclude that 2 is a factor of 6. Okay, now this enables me to write 6 in a very interesting manner, because I can express 6 in this manner. So I can say 6 is equal to 3 times 2. Okay, now what I've done is I have expressed this numerical value, number 6, as a product of its factors. Okay, so this is what I've done. I have simply factorized 6. Okay, so this process this process that I've applied to the number 6 is the very same thing that we will do when it comes to polynomials, or when it comes to algebraic expressions. What we will do is we will find a factor of a polynomial, and then we will make use of that factor to express the polynomial in this manner, okay, or to factorize that polynomial, okay. So that is where the factor theorem comes in, okay. So when we started the section, we said that a of x over b of x is equal to q of x plus r of x over b of x. But if b of x is a factor, is a factor of a of x, okay, then the above equation becomes, it becomes like this. It becomes a of x over b of x, okay. A of x over b of x is equal to q of x. Why is this the case? Because this is equal to 0. And if this is equal to 0, then it means that this whole fraction will will disappear, okay? Because the whole thing will become to will be equal to 0. Okay. Now we have this situation, okay. So this means that I can do the very same thing that I did with the number 6, okay. I can factorize a of x, okay. So if I multiply by b of x on both sides, then I end up with this situation. A of x is equal to q of x times b of x. Okay, so what I've done is I have expressed a of x as a product of its factors. Okay, so this is what we call factorization. 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 Okay, so this is basically what we will be doing in this particular session. We will get a polynomial function, or we'll get an algebraic expression. Let's call it a of x, and then we will have to use the factor theorem to determine to, de to determine an expression that is a factor. Let's call that b of x, and then from there we will use this situation to be able to determine the value of q of x, and then after that you will express a of x as a product of its factors, okay. So let's do an example to illustrate what I'm talking about. So let's say we want to example number 1, let's say we want to factorize this situation. A of x is equal to x to the power of 3 minus 3x squared plus 4. Okay, now the first step that we take is for us to determine the factor, okay, the one factor, and then from there we will use other methods to determine the value of q of x, okay. But then for now we'll use the remainder theorem to get this one, b of x, okay. So how do we go about that? Now we go about that by plugging in a value of x, or estimating or guessing a value of x that when we plug into this function, it will make a of x to be equal to 0. Okay, so let us see. So if I plug in x is equal to 1, let's see what will happen. I'll get 1 cubed minus 3 times 1 squared plus 4. Okay, so let's see. 1 cubed is 1 minus 3, that is minus 2. Minus 2 plus 4, that will give us positive 2. So this is clearly not equal to 0. Okay, so we we know that positive 1 is not the number that we are looking for. Okay, so let's try minus 1. Now let's see what happens if we insert minus 1. Okay, so negative 1 cubed, this will give us negative 1, and then a negative 1 squared, so this will be positive 1. So positive 1 times negative 3 will give us negative 3, and then this is plus 4. Now we can see that negative 1 minus 3 is negative 4, plus 4, this gives us a value of 0. Okay, so minus 1 is the value that we are looking for. Okay, so now we can conclude and say that x plus 1 is a factor of a of x. Okay, so this is very important. Now, hopefully you are asking yourselves or you are questioning, Uguti, how do I or how did I get it to become x plus 1, or how do I know that the factor is x plus 1? Remember that we are looking for b of x, and b of x is generally expressed in this manner. Okay, so we have cx minus d. Okay, and you will recall that when I was discussing the remainder theorem, what we do is we substitute the value of d over c, okay, into the function, and then we obtain a remainder from that. Okay, now what we did in this situation is basically the reverse of what we did when we were doing the remainder theorem, because when we were doing the remainder theorem, we just substituted d over c because we had the expression of b of x. Okay, but now we are using that theorem in reverse, because what we have done is we substituted minus 1. Okay, and because we substituted minus 1, we can say that our d over c is equal to minus 1. Okay, now this guy, which is x minus minus 1, if I put this thing like this, then it is clear to us that d is equal to minus 1 and c is equal to positive 1, the coefficient of x. And because of that, we can see that this is basically working backwards. Okay, we are basically using the remainder theorem backwards, so to speak. Okay, hopefully that makes sense. And then we we can conclude therefore that in this our case, cx minus d is basically x plus 1. Okay, so that is the case. One, and then okay, so x plus 1 is a factor of a of x. Okay, now we know that a of x is equal to b of x times q of x. Okay, so if we have b of x, which is a factor, then there's no remainder. Okay, um, okay, so a of x was given to be x cubed minus 3 minus 3x squared plus 4. Okay, so and we have found that b of x is actually x plus 1. Okay, and then we do not know what q of x is, so we have to find ways to determine the value of q of x. Now there are two ways to determine the value of q of x. There is the long way and there is the short one. The long one is basically the idea of long division that we introduced in earlier sessions, and then a shortcut method is another method that I introduced as well in um, that I will introduce. I'm not sure whether I've introduced it previously, but then I'll discuss it in this session as well. So what I will do is I will first use the long division method, and then I will use the shortcut method, and then you will decide for yourselves which one is more convenient. Okay. Now recall that we want to determine q of x. Now q of x is basically a of x divided by b of x. Okay, so let's use long division to get that. Okay, so you will recall that we have a few steps when we are facilitating this process of long division. So the first one is the division. So we say x cubed divided by x. This will give us x squared. Okay, and then after that we multiply. We take x squared and then we multiply it by x plus 1. And then if we do that, we will get that this is equal to x cubed, and then x squared times 1, this will be positive x squared. Okay, and then the next step is for us to subtract. Okay, so we say x cubed minus x cubed, this will give us 0. Negative x squared minus x squared, this will give us negative 4x squared. And then the next step is for us to bring down the next term. Okay, so this is positive 4. And then we start the process over again. We say that negative 4x squared divided by x, this will give us negative 4x. Okay, and then we multiply now. So negative 4x times x will give us negative 4x squared. Negative 4x times 1 will give us negative 4x. Okay, and then after this we subtract. Okay, now we see that negative 4x squared plus 4x squared, this will give us 0. Okay, and then we can see that in this term there is no x term. Okay, so we can look at this situation like this. Okay, we can view this situation like this. So we can say it's plus 0x and then plus 4. Okay, so we can say 0x plus 4x. Okay, the reason why I'm saying plus 4x is because this negative sign will make this guy to be positive and that guy to be positive as well. So as a result, it will be 0x plus a positive 4x. So it will be plus 4x, okay, and then 4 minus 0 is basically positive 4, okay, and then we start the process all over again. We say 4x divided by x, that will give us a value of 4, okay, so 4x divided by 4x divided by x, that will give us a value of 4, and then we multiply, so we say 4 times x, this will give us 4x, and then 4 times 1, that will give us a value of 4. And then the next step is for us to subtract. And then if we subtract, we see that 4x minus 4x will give us 0. But then 4 minus 4 as well will give us a value of 0. So we end up with a remainder of 0. And this is good news because before we started the division process, we already established via the factor theorem that x plus 1 is a factor of a of x. So because x plus 1 is a factor, we are expecting for us to get a remainder that is equal to 0, or we are not expecting any remainder. Okay, so this confirms that we performed our operations accurately. Okay, so we are happy about that. Now, this expression, q of x will come in. Okay, so we have x squared minus 4x plus 4, and then we can continue with our simplification. We can continue with our factorization. Let me just take this. Uh, yeah, and place it here. Okay, and then we can continue with our factorization. So we have, we see that we have a quadratic expression here. So we know how to factorize trinomials from our factorizing session of algebra that we did a while ago. So hopefully we can still remember that. Okay. We have x plus 1, and to factorize this, we put two brackets. The sign that enters here is the sign that is here. Okay, so this sign goes directly here, and then to obtain this sign, we say a negative times a positive will give us a negative. So basically it is this sign times that sign, and then that enables us to get that other sign. Okay, and then we have an x there, and then we look at this last term, this 4, and we think to ourselves, we see what are the two numbers that when we multiply them, they will give us positive 4, but then when we add them, they will give us negative 4. Okay, so those two numbers are negative 2 and negative 2. If we multiply them together, we'll get positive 4, but then if we add them, we will get negative 4. Okay, so we have negative 2 there, we have negative 2 there, so we are done with factorizing. Um, this can be expressed as x minus 2 all squared because we have two of them like that. Okay, so this is how we factorize cubic expressions. Now, I said that I will show you the long way, which is what I've just demonstrated, but then there's also a short way. Okay, so let's talk about the shortcuts. Okay, we are we want to use the short method to determine this expression, the q of x. Okay, remember that this one you obtain it from the factor theorem or using the factor theorem, and then this one now is what we can obtain using the shortcut method. So the first thing that we do is we ask ourselves, Uguchi, what do I need to multiply x by in order for me to get x cubed? Then the answer is very simple. We need x squared. Okay, and then the following question is a very simple question as well. We ask ourselves, Uguchi, what do I need to multiply positive 1 by in order for me to obtain positive 4? And the answer is very simple as well. We need positive 4 to do that. Okay, and then we come to a very important part, which is how do we determine the middle term of this trinomial? Now we look at the x squared term on a of x. Okay, so we have negative 3x squared. So this is what we are working towards. Okay, and we have to keep that in mind. Okay, so we can see that if I take this one times x squared, I get a value of x squared. Okay, so this means that I am still short of a negative 4x squared in order for me to obtain this negative 3x squared. Okay, now how will I get this negative 4x squared? This negative 4x squared will only be obtained if x is being multiplied with negative 4x. Okay, if x is being multiplied with negative 4x. So this is the 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 shortcut method, and it is very convenient as far as time is concerned because it's very quick, but it is vital for you to understand it properly so that you do not make unnecessary mistakes. Okay, so this is what we obtained using the shortcut method. So let's see whether this is in agreement to what we obtained using the the um, the long division method. Okay, let's see. It is exactly the same thing. Okay, as you can see that this is exactly the same as that. Okay, so it is entirely up to you which method you prefer. Okay, but for me, I would advise that while you are practicing for tests and exams, you do the long division and you understand the long division process, but then for the sake of speed and time and all of those factors, you practice the shortcut method as well. Okay, so that you can be able to use the shortcut method when it is relevant. Okay, so we see that this is x plus 1. Okay, this is x plus 1, and then this can be factorized as we did previously. So we said that this is x minus 2 and this is x minus 2, and as a result we have x plus 1 and we have x minus 2 all squared. Okay, so let's do another example. Okay, so let's factorize. Let us factorize um this cubic polynomial to 2x cubed, just a of x is 2x cubed plus x squared minus 5x plus 2. Okay, so remember that the first step is for us to determine the factor, and we do that by plugging in values or substituting in values. And if we get a value that we substitute such that it makes a of x to be equal to 0, then that is the value that we are looking for. And then we'll use that numerical value to figure out the factor of a of x. Okay, so let's do that. Let's start with a of 1. If I insert a of 1, then this is what happens. If I insert 1, I mean. Okay, so this will give us 2. Okay, 2 times 1 is just 2, and then plus 1, and then minus 5 plus 2. Now this will give us 0 because 2 plus 1 is 3, 3 plus 2, that's 5, and then minus 5 will give us a value of 0. Okay, so this is what we want. Now we 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 perform this substitution via trial and error, but then I have to say this, that it is not just a random trial and error. The trial and error that we perform has to be, or the numbers that we try and insert, they have to be factors of the of of the constant term, okay, or the the term without x at the end of the expression. Okay, we can see that 1 is a factor of 2. Okay, so that is why we can try 1. If 1 didn't work, we would have tried -1. -1 is a factor of 2 as well. If -1 didn't work, then we would have tried -2, we would have tried 2, and so forth and so forth. So, although this is a trial and error, but it is a very structured trial and error. Okay, we it wouldn't make sense for us to try and plug in positive 3 because 3 is not a factor of 2. Okay, so that is a very important thing to keep it to take into consideration when you're doing this. Okay, so from this we can conclude that x minus 1 is a factor of a of x. Okay, is a factor of a of x, and then because this is the case, then we can express a of x in this manner. We can say that 2x cubed plus x squared minus 5x plus 2. This is equal to the factor, which is x minus 1, and multiplied by this other factor that we will determine. Okay, so for this example, I will not perform long division, but then what I will do is I will just use the shortcut method. Okay, so we we to get to this term, we ask ourselves, what do we need to multiply x by in order for us to obtain 2x cubed? And the answer is very simple. We need 2x squared. Okay, and then we we go on to look for this last term, and we ask ourselves, what do I need to multiply -1 by in order for me to obtain +2? And the answer is very simple. We need -2. Okay, and now it is time for us to find the middle term. Now remember, that we do this by considering the x squared term over here. So we are working towards finding x squared. Okay. Now, if I if I look at this, I can see that I will take, if I take -1 and I multiply it by 2 squared, I get negative 2x squared. Okay, so this is what I obtained. Now, in order for me to get a positive x squared, I will need a positive 3x squared somewhere. Okay, now I can only obtain this positive 3x squared if I take this x and then I multiply it with a positive 3x. All right, multiplying it to the positive 3x, and that is how we determine the middle term. Okay, okay. So we have x minus 1, and then we have 2x squared plus 3x minus 2. Okay, so we must factorize this trinomial. Hopefully you can still remember how to factorize trinomials from algebra. Okay, so if we have this situation, 2x squared plus 3x minus 2, what we do is we focus on this value and that value. We break them down, so 2 can be written as 2 times 1. Negative 2 can be written as negative 1 times positive 2. Okay, and then we cross multiply. Okay, and then when we cross multiply, it will be negative 1 times 1, which will give us negative 1. 2 times 2, which will give us positive 4. And then we add these two values and see what value do we get. So negative 1 plus positive 4 will give us positive 3. Now, because we have positive 3, this serves as a confirmation that we have the right combinations. Why? Because positive 3 is the coefficient of the middle term. Okay, so this is a way to test if you have the right combinations or not. Because whatever value that you obtain at the end has to be the same as the coefficient of the middle term. Okay, so this is what we did when we were doing algebra. Okay, so we can structure this up. We can say that we have x minus 1, and then we can have two brackets for that trinomial. Now the sign, you will remember that the sign of this guy is directly from this one. Okay, and then to obtain this, we say positive times negative, and then we get a negative, obviously. And then um we go to our combinations. Okay, we go to our combinations. Now we can see that we have a bracket with a positive, and then there's another bracket with a negative. Now the one that has a negative will correspond with this combination, because this is where we have a negative. Okay, so here we will have 2x, okay, minus 1. Okay, and then the other combination, this one, is the combination that we will be associated with the bracket with the positive sign. Okay, so here we will have 1x, and then we will have plus 2, like that. Okay, so this is how we factorize trinomials whereby the coefficient of x squared is not equal to 1. Okay, So at this point, we are done with factorizing the cubic polynomial or the cubic expression. So the the steps are very simple. The first thing that we do is we use the factor theorem to determine the factor of the expression, and then from there we simply use the shortcut method to determine quadratic the quadratic expression, and then we look at the quadratic expression, and if we can factorize it, then we can employ or deploy the methods that we obtained when we were doing algebra.